Okay, let's talk about artificial intelligence. It's a term you hear everywhere, right? And honestly, it can feel pretty overwhelming. But what if I told you that you're already using AI like a pro every single day? I'm serious. From the Face ID that just unlocked your phone to the Google Maps route that helped you dodge traffic, AI is already completely woven into our lives. So today, we're going to pull back that curtain, we're going to demystify the buzzwords, and we're going to show you how this stuff really works and what you actually need to know.
Right. So let's just start with the elephant in the room, the fear. I mean, we've had decades of sci-fi movies warning us, and then a mind like Stephen Hawking drops a quote like this. It's pretty hard not to feel at least a little bit uneasy. And that anxiety is exactly why it's so important to separate the Hollywood fiction from the real-world facts, and to really understand what we're talking about when we say AI.
And yeah, this right here shows you the huge gap between those two worlds. On one side, you've got the movie version, these conscious, evil, world-dominating machines. And on the other side, you've got the AI of today, these incredibly handy, specialized tools that suggest what video to watch next, keep junk out of your inbox, and find you the fastest way home. So, what is the fundamental difference between the AI in the movies and the AI in our pockets? Well, to get that, we need to look under the hood.
To really get that difference, we have to talk about how these systems actually learn. Because, it's not like a machine just suddenly wakes up one day and decides to take over. It's all about one thing: processing massive, and I mean massive amounts of data. This slide shows this really fundamental shift in how we think about software. See, traditional programming is all about giving a computer a strict, step-by-step set of rules. If it sees anything it hasn't been told about before, it just fails, it breaks. But machine learning, which is really the engine of modern AI, completely flips the script. We don't give it the rules, instead we give it a ton of examples of what we want, and it figures out the rules for itself.
So how does it learn from an example? Well, it learns by looking for features. Now that's just a fancy word for a characteristic that stands out. If we want an AI to recognize a bird, we don't teach it the abstract idea of birdness. No, instead, we teach it to spot the building blocks. Does it have a beak, wings, feathers? It's all about breaking a big, complicated idea down into smaller, easy-to-identify patterns.
And that learning happens through a process we just call training. First, we feed the AI a giant pile of data. Let's say thousands of pictures that we've already labeled bird. Then we test it. We show it a new picture, maybe a penguin. Based on what it knows so far, it might guess not a bird because the wings look kind of like flippers. So we give it feedback. Nope, that one's a bird too. And here's the kind of magical part. The AI then goes back and tweaks its own internal logic. It literally changes how much importance or weight it gives to each feature, all so it can make a better guess the next time around.
Okay, now that we have a feel for how these machines learn, we can start to untangle all those buzzwords you're always hearing. So think of this next part as our official guide to the AI family tree.
At the very, very top, the big umbrella that covers everything, is artificial intelligence itself, or AI. This is the whole grand idea, the entire field of science dedicated to building machines that can do things that usually take human intelligence, like recognizing a face or understanding what you're saying.
Now, tucked inside that giant field is the most important branch, machine learning, or ML. And this is where basically all the action is today. It's that specific approach we were just talking about, creating systems that learn their own logic by finding patterns in data instead of being programmed with rules. Seriously, almost every time you hear about some new AI breakthrough, what you're really hearing about is a breakthrough in machine learning. And if we go one level deeper, we find deep learning. This is a really powerful, specialized kind of machine learning that uses something called neural networks. These are basically layers and layers of algorithms that work together, kind of inspired by how the neurons in our brains work. And this is the tech that's amazing at making sense of really messy, unstructured stuff, like images, audio, and just plain old text.
This table ties it all together perfectly. Here's the key. All deep learning is machine learning, and all machine learning is AI. But, and this is important, it doesn't work the other way around. That old-school chess program that just follows a huge list of pre-programmed rules, that's AI, but it's not machine learning, because it can't learn anything new. Your spam filter that gets better over time, that's classic machine learning. A self-driving car that has to identify a pedestrian in a fraction of a second, yeah, that's a job for deep learning.
So we know these systems learn from data, but how exactly do we teach them? Well, it turns out there are a few different rules of the road, or methods, for how that learning can actually happen.
By far the most common method is something called supervised learning, and it's exactly what it sounds like. We supervise the AI. We give it a huge data set where all the correct answers are already labeled. It's basically like giving a student a big stack of flashcards to study, but with the answers already on the back. This is how we train systems for things like spam detection or figuring out if a loan application should be approved. So what happens when you don't have an answer key? Well, that's where unsupervised learning comes in. This time, we take the labels away. We just throw a massive, messy pile of data at the AI and ask it, hey, find the interesting patterns in here. For example, you could feed it 1,000,000 news articles and it would start grouping them into topics like sports, business, or politics, all by itself, without ever being told what those topics were.
And finally, there's reinforcement learning. And honestly, the absolute best way to think about this is training a dog. The AI, we call it an agent, is in some kind of environment and it just starts trying things. If it does something that gets it closer to its goal, it gets a reward, a little digital treat. If it makes a bad move, it gets a penalty. And over millions and millions of tries, it eventually learns the absolute best strategy to get the most rewards. This is how AIs have mastered insanely complex games like chess and Go.
Okay, so we've covered the what and the how. Now let's zoom back out, connect all of this to that scary Stephen Hawking quote from the beginning, and talk about the very real challenges that we're facing today.
And this right here is probably the most important thing to remember. There is a huge difference between the AI we actually have and the AI from science fiction. Everything we've talked about today, literally everything that currently exists, is what experts call weak AI or narrow AI. It's an AI that's been designed and trained to do one specific task really, really well. The AI that can beat the world champion at chess cannot drive a car. It can't even tell you a simple joke. Strong AI, or artificial general intelligence, that's the theoretical, human-like consciousness that can learn anything. And let's be crystal clear about this. It is still purely science fiction. It does not exist.
But just because we don't have the Terminator yet, doesn't mean narrow AI is without its own serious problems. One of the biggest is the black box problem. Sometimes an AI's internal logic gets so complicated that even the people who built it don't know exactly why it's making a certain decision. For instance, there was an AI designed to identify wolves that actually just learned to identify snow, because most of the pictures of wolves it was trained on were in snowy places. Another massive issue is bias. If we train an AI on biased data from our world, it will just learn to repeat those biases. A major company had to scrap a hiring AI because it learned to discriminate against female candidates simply because it was trained on past hiring data from a male-dominated industry.
And that brings us to the final and most important idea. The AI we have today is a tool. A profoundly powerful tool for sure, but a tool nonetheless. It's a pattern recognition machine on a scale we've never seen before. It has no consciousness, no intent, and absolutely zero concept of right or wrong. So worrying about what some evil AI might decide to do to humanity is kind of missing the point. The real, urgent question isn't what AI will do to us. The question is, what will we, as people, as a society, choose to do with it?